Yeah, I don't know. That's what I wrote back there. That's bizarre. All right. So that's our secret. Don't you dare tell anybody. All right. Let's check out 14. On 14, we are trying to find and write it in that form, but we're going to do a different approach. On 14, we have 2x over x plus 4. I don't know why I wrote the wrong number up there. I think I probably typed the right number. Did everybody do 197? Did you do a completely different assignment? Okay. So remember, never trust my page number. Trust the section. 4.2 homework is at the end of which section? 4.2. Yeah, that's why we call it that. All right, let's check it out. Instead of doing the division, there is some key feature stuff that I would much rather use, and realistically, I hope you would much rather use. You're going to help me out with this real quick. I asked this a few minutes ago. Vertical asymptotes, they happen when the what is 0? Denominator. What value of x makes the denominator 0 here? -4. So check it out. We already have our vertical asymptote. Now, here's the part that we have to kind of connect if we want to get to that form. That means this has been moved left or right. If the original is at x equals 0 and the new one is at -4, it's been moved left how many units? So we're not really formally doing the math right now, but that's just an observation I've made. Okay, how do we find the horizontal asymptote of a rational function like this? You check the degrees of the numerator and the denominator. Now, silly me, I've forgotten. Kyle, what's the degree of something if we're talking about it? Do you recall? Like if I said, what's the degree of this numerator? Do you know not just the answer, but do you know even what I'm asking? So what about the x? So the 2 is not the degree, but it's certainly something we're going to care about. This is a leading coefficient. The degree is always just defined as the biggest power of x. So even though we don't write it here, Kyle, what is the exponent up here? Good. Fred, what's the exponent right here on the denominator? X to the y4. So we're just looking, I don't write it. Does this x have an exponent that we just never write? What is the exponent on that x right there? Good. So the degree is that number. It's 1. If my degrees are equal, it's one of my 3 scenarios that we saw. How do we find the horizontal asymptote? You check the leading coefficients, and it's just the ratio of those. So here we go. What is the leading coefficient of the numerator, Mark? 2. What is the leading coefficient of the denominator, Kennedy? Good. And if we simplify this down, RJ, the horizontal asymptote, instead of writing 2 over 1, which is okay, is there a simplified way we could write that? 2. Boom. Check it out. The normal asymptote is at 0, right? And now it's at 2. Which way has it moved and how far? It's moved up 2. Now, we should be able to reason this out. If we want to go this way, which whether this is easier or harder than long dividing, I don't know, but it's just a different approach. It'll make way more sense on the next one that we do. If I look at this, how can I write this? F of x, I know it's a over x minus h. It went up how much? How far did this function go up, my k value? So check it out. I'm just going to say, here's my plus 2. Must be there. And then let's take a look at this one. And this is where I'm going to struggle just a skosh. What do you think a might be here? So x minus 4 is certainly down here, right? What about the a value? And this is the weirdest part. 8, why? Did that happen on our other one? Looks like it, right? Cool. If you don't see what Liam just commented on, check it out. If we want to see a connection, and we'll check, did anybody do the long division way for this or synthetic? Did it wind up at 8? When you did the division, did it wind up 8? What is it up here? Okay, so I've never seen this connection because I've never seen this form. What Liam noticed is he's looked at this one and said, it looked like I just did this times this to get this number. And that's what we did on this one, right? Let's check it real quick. Did anybody do the synthetic division on? No, because we're doing 14. Why would any of you have done that one? Let's check. I don't know if Liam's idea works, but we'll check real quick just to see, and we'll dig into it. Hey, look at that. Now, we did get something wonky with it. We don't really have anything wonky. There's a difference here. Why is this different than what we wrote? Can we change it so it looks the same, you think? They have factored the negative out and moved it, which would naturally happen through the division. If this is the answer you gave me, I'm cool with it. Sonny, and then Kennedy. We'll come back.
Our final answer, x minus 4. Why is x minus 4?
Because I know that it's moved how far to the left. Ooh, I'm wrong there, aren't I? If I want to move 4 left, h should be negative 4, right? And if I know it's going to be x minus h, it should be x plus 4, shouldn't it? I was wrong there. Now, we're going to get some wonky stuff happening out of it. For these, I'm going to be honest. Just identifying the transformations, it's nice to get the review of the division stuff. We're missing a negative in here that we can dig into, but here's the honest truth of it all. If we're just going to graph it using that other approach and not worry about these transformations and stuff, maybe there's not as much value out of doing these as beyond just the practice with the division, like realistically with it. Kennedy, I lost you somewhere. So the 8, Liam, since you were the one that suggested it, do you want to give us a rundown on how you came up with that 8 number again? Because this is where we were. I'm going to switch it to plus 4. Can you explain how you got that 8 again?
Multiply the leading coefficient of the numerator and multiply that by the constant of the denominator.
Okay, so Kennedy, can you see this okay? On the first one, when we did the division, Liam noticed that if you multiplied this number, which in ours is plus 4, right? And if you multiplied it by this, you got that 10 here. Now, we changed the sign on this one, and I didn't catch that a second ago. If we did 4 times 2, what do we get? 8. And if we change the sign, because that seems to be what happened on the first one, we would wind up with 4 times 2 is 8, and the opposite is negative 8. And this feels kind of like magic, but again, because we don't really truly graph from this form normally, maybe it's okay to feel like magic for a second. Okay, that did not feel super satisfying. Let's do another one, eh? Cool. All right, should we graph this? Okay, do you want to graph it from this form or do you want to graph it from these informations? From these ones? Okay, so we're going to pretend like we didn't do this, and I might put a little caveat on our thing tonight. Looking at this, you have a nice question out of these, Michael. Michael's question, I think, and correct me if I'm wrong, or do you want to ask your question that you asked me a minute ago? So let's see where we're at, and we're going to find the answer to your question, and I hope you remember what you asked me. If I want to graph this, I need to see the vertical asymptote at -4, and I need to see the horizontal asymptote up at 2. So all I'm going to do is I'll put my x and my y, and let's check it. Here's -4. There's an asymptote, x equals -4, and here's an asymptote at y equals 2. We'll try to get it through the right line. Y equals 2. Now, be very diligent when you're labeling your stuff, because if we don't have labels, it's going to make this so much harder to pick out what we're doing. All right, there's my asymptotes that I don't touch. Do you remember your question yet, Michael, by chance? Yeah. Okay, what was your question that you asked me a few minutes ago? Yeah, so as we're looking at this, I know that I'm going to have that goofy hyperbola shape, and I realistically have 4 possibilities. That's it. I can have, maybe they're both up here like this. Maybe they're both down here like this. Maybe one is down here and one's up here like this, and this is a really hard mental task right now for me. Or they're like this. These are the only 4 possibilities. Okay, we need to decide which one it is, right? There's one more piece of key information here that when we did them yesterday we used, but has not been included right here. What's the only other thing that we haven't written down that we did yesterday when we were writing them? Say it again. The zeros. We just need an x-intercept. If we find the x-intercept, we're going to be golden on this. How do we find the x-intercept from this? A fraction is 0 when which part is 0, Naomi? I don't know if you were stretching or raising your hand. Okay. When the numerator is 0. This is my numerator. If I set 2x equal to 0, what's the value of x we get? So careful, we'll even do scratch work with it. So zeros, or x-intercept if we want to. If 2x equals 0, this implies that x must be what? 0, because we just divide both by 2, right? So check it out. I know that it crosses the axis here. Are there any other places where it's going to cross the x-axis? Because we only found that one singular place, right? So on this side, if I have to pass through this point, can it be up here? No, the only option is to be down here. And it'll get close to these asymptotes. On this side, we already, if you didn't catch it before, we've already locked this one in. I'm cool with that. Over here, the comment that I made a second ago is it could do this or it could do this, one of these two. Is it ever going to cross the x-axis anywhere but here? And with that in mind, should it be above or below then? Above. Without having to get the actual point, logically, if it can't touch the x-axis again, it must fit right here. There's no other option because I would have found another x-intercept. Does that clear up where the confusion was? Okay, 100% of the time, I will default to graphing them like this. Like we don't have to do the division, we don't have to graph the parent and then move it and do the reflection stuff. We can just get all the information and commit to it right here, right now. Cool, cool? All right, should we do a little harder one? Okay, so for 17 or 16 rather, and 17 if you're going to rework these just in case, I'm going to change your directions just a little bit. I don't need to know that form. I don't care if we get to that a over x minus h form. All I want you to do with this is however you see fit, identify the asymptotes. Whether it's using the division or it's doing this that we just did now, I don't care which way you go through it. Find me the asymptotes and just tell me, did my graph move left, right, up, or down? Don't have to see it in that form. Okay, let's do a little bit harder one. And before we do, same thing, we're going to go like 30 seconds. In this approach, where are your questions? 30 seconds, talk it out with your neighbors. I want to hear something that somebody struggled with or didn't get. Go. Talk, 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 talk. Nobody's going to believe you. What's up?
Also clear up like there were three.
We're-
And
When you say 3, what do you mean?
three lines.
Are you talking asymptotes?
Yeah, three asymptotes.
So if there's like 2 verticals and 1 horizontal? Okay.
Yes. How do you know if it goes like this or this or?
We'll have to get a couple of points. We'll see that happen in just a second. Yes. You're good. Just go.
Paul is asking why it's
Why what?
curved.
If it doesn't curve, it would have to cross the asymptotes, right? But remember these dashed lines, these asymptotes is what we call them. It's what makes me divide by 0. I can never touch it. If I want to pass through this, but I can't touch this, what's the only option? I have to curve. Now, I don't curve up because I don't want to cross this asymptote either. These ones get weird. Sometimes we will, the horizontals. But typically, especially with the nice ones, we just stick between the little region that we're in. Does it really make sense, or are you just agreeing? They can't touch the purple lines. Yep, the blues are just the x and the y-axis. Yep, these are lines that we don't touch, and it's why I've dashed them and made them different color. All right, questions. What do we got? Where did we struggle on this? One of the questions that I got is, why do these have to be curved? Why does this have to be curved instead of just doing this? It can't touch this asymptote, right? If it can't be a straight line and touch it, the only option is for it to curve down. Now, there's a little bit of weirdness that happens in the other asymptote, the horizontal. In the middle area, I don't care if we cross it. It's okay. That's a weird little thing. It's a bad name for this. This is just an end behavior question. But this one, can't cross it. All right, let's do another one, and it gets these questions a little bit more challenging. Do you want to do 16 or 17? 16. If you didn't do 17 last night, I'm not going to require that you do it again, but I'll tell you, you should, for sure, because if you can watch me do a problem and say, oh yeah, I could do this, you probably feel confident with it if I'm doing it, for sure. But remember, I don't take your tests. I mean, I do, but not for you. All right, let's do 16. We are trying to identify the asymptotes in sketch. That's our goal. So 16, here we go. F of x is 6x squared over 3x squared plus 1. Whoa, over 3x squared plus 1, I'm sorry. 6x squared divided by 3x squared plus 1. Okay, if we wanted to go through the whole division process, and some of you may still prefer it, and it's okay if you do, why can't we use synthetic division? We have to have a degree of 1 down here if we want to use synthetic. So if we go that route, which we can, you have to have long division. And what you would have to long divide, and you do not need to write this because I'm not actually going to do the division. We would do 6x squared plus 0x plus 1, plus 0, because that's my numerator, long divide by 3x squared plus 0x plus 1. This is the division you would have to do to get it to be in the form a over x minus h. Now, we could, but we can get all the same answers so much cheaper than doing all this labor. So let's do that. The very first thing, and this is for really anything that we're doing with these, I want a simplified version if possible. So right now, does the numerator factor? Okay, so that's a bummer or nice, I don't know. Does the denominator factor? Doesn't do that either. Huh, that sucks. Well, what do we do then? Sorry? Yeah, let's start looking at them. You said the leading coefficients. Are you talking about factoring or are you talking about a different part of the graph process? Okay, so we can't factor either of them. So my only thought is, let's just try to jump in. I need to identify 3 things here. What are the 3 things that we identified on the last problem? The x-intercepts, the horizontal asymptotes, and the vertical asymptotes, right? And I don't really care the order that they go in. I think this is different than the first order that we had, but let's run through it. Horizontal asymptotes are always the easiest before we do anything. What's the degree of this numerator, Ronaldo? What is the degree of the numerator, the top part of this? 2. Love it. Amy, what is the degree of the bottom part? 2. And those are equal, I think? If they're equal, how do we find the asymptote out of it? The ratio. Love it. I think that's what I heard. And I also heard leading coefficient. We're just going to put those together. The ratio of the leading coefficients. What's the leading coefficient up here? 6 over 3. Where's the horizontal asymptote then? Y equals 2. Now, if all we're doing is identifying the transformation, this graph has been moved up or down? Up how many? Look at that. We already have it. Up 2. All right. Vertical asymptotes happen when I try to divide by what? So I always divide by the denominator. You're right with that. But what's the number I can't divide by? 0. So I need to know when is the denominator 0. So I'm going to do some scratch work over here for the vertical asymptote. It's not scrath. Scratch. Weird. And I'm just going to be very specific. Scratch for vertical asymptote. All right. I need to know when is this the case. 3x squared plus 1. And I'm trying to find when it's equal to what number? 0. Well, help me solve it. Subtract 1. Okay. 3x squared equals negative 1. Can you tell anything wonky that's going to happen? That's going to be imaginary. Am I ever going to be able to put the imaginary number on my graph? No. But if we want to keep going, let's just pretend that we didn't notice that. I want to keep solving for x. Julia, what would you have me do? Divide by 3, so x squared equals negative 1/3. And we're one step away, Lando. If I wanted to solve for x instead of x squared, what would we need to do? Good. I would have x equals, what do I always put in front of the square root here? Plus or minus the square root of negative 1/3. Now, at this point, this is not a real number. I can't put it on my graph anywhere, which means what do we just find for the vertical asymptote if there's not a real number where it happens? Are there any values that make me divide by 0? Any real numbers that make me divide by 0? So if you shake your head no, what could I write here? None. There aren't any. It just can't happen. Okay, so no movement left or right, or not at all. Like, and it's weird to even think about this thing as a transformation because maybe it's not quite a transformation. All right, Hawaii. If I want to find the x-intercepts, it's where which part is 0? So 6x squared is my numerator. So let's just do that. I'm going to do my scratch work right here. 6x squared, I need to know when it's equal to what number? 0. I'm going to divide by 6. And I'll take the square root. And it's plus or minus 0. Now, instead of just writing 0, can anybody tell me why I might write that twice? So, yeah, but plus or minus 0 is just 0, right? Why would I even bother to write it twice? A multiplicity of 2, and this is an old idea, this isn't a face, this is a multiplicity of 2. That's how many times it showed up, that's all that word means. Multiplicity of 2 means that we touch and turn at the x-axis. Touch and turn. Now, for this one, and glad that we're doing this one together, this one's wonky. Let's try to take all this information and make it a graph. So I'm going to clear that, and we'll use our lovely coordinate plane. And this is the last one that we're going to do together because they all follow this same approach. Okay, so here it is. Okay, horizontal asymptote. The line that I won't touch is at y equals 2, yeah? Here it is, and I'm going to dash it. There's y equals 2. And I am going to go back through. I'll try to be more consistent. I'm always try to label my axes if I'm doing these because it gets real easy to goof up what lines are which. With pencil, more important than on the board, but I do always dash my asymptotes so that I try to avoid that confusion one more time. All right, now I only know one value right now, and it's at 0, 0. And there's some weird stuff that's going to happen with this. There's no trying to decide which part is it looking at because there's no two sides, right? It's either everything is going to go upward or everything is going to go downward. We need to make a decision, and it doesn't happen every time, but if I need to know where this goes, can I get some other values to plug in? And I'm just going to plug them right in here. So all I'm using is this function. Give me another x so we can get a good idea of this. Like I want to plug in f of what value? Don't care where. If I want to do f of 1, it's going to tell me where this graph is. And then I'll be able to get the rest out of it. What is f of 1? That's 6 times 1 squared, which is just 6, over what's 3 plus 1? And that, to me, looks like 3 over 2. That's 1.5. If I go to 1, my graph has gone here. This pretty much tells me everything that I need. I want you guys to do one of two things for me. Either using just this one point that we just got, sketch your graph, or if you need to get a couple extra points to make a little bit clearer picture, I would pick a couple more x values, and I want to see what you guys come up with over the next 90 seconds. Talk with your neighbors from just these 2 points and this information. Can we sketch this graph? That's your challenge. 90 seconds, talk it out. Either get another point or sketch it, what you think it is going to be now. How's it going? How's this stuff feel? So just you two, and I'm not like just because we haven't been back here yet. Are you going to get another point, or do you think you can tell me what it does? Okay, I'm fine with that. What are you going to pick? And when you do 2, you get 24 over 13. which is really close to 2, right? So I would plot that point. And when you plot that second one, can you tell what it's going to do now? And we'll see. What are you thinking?
Take asymptote and negative number 0. Wouldn't the line be like flat?
So the line will eventually it will be. Right now, if we wanted a little bit more information, we did f of 1 to figure out as 1.5. Would doing f of 2 maybe help? If I wanted to know, so we plugged in 1 to see what it was, and it wound up here, right? Would getting another one at 2 maybe help if we knew where it was? I would like try to find f of 2 real quick. All right. So looking at this, how many of you guys had an idea of where it is without any more points? Okay, like a couple people. Let's check. I have not graphed this function. I don't know for sure what it looks like. We'll check it against Desmos here in a second. But I'm going to show you the logic that I would use. I know that eventually it's going to mellow out on this line, on both sides. It's going to get to this line. Now, what I don't know for sure is whether it's going to pop up and over it and then come back down, or if it's just going to do this. The other little piece that I know is, does it cross here or does it just touch and turn around? So in the middle, without anything else, and this is just me thinking right now, we'll get another point. I know that this graph, and I'm going to do blue right now, is going to do something like this. It's going to do that. I know it's just going to turn around. That's where I'm at so far. Now, as I said a second ago, there's two options. Horizontal asymptotes are weird. I'm going to fix this one just so it looks a little nicer. So it has two possibilities here. It's either going to do something like this and then settle out like this, where it gets really close, or it's going to just really quickly mellow out like this. It's going to get close to this value. I guarantee it. That's what it means to be a horizontal asymptote. If I wanted to figure out which of those two options it was, I need probably one more point. Is there an easy point that I can get out of this? I already did 1. I think 2 is a natural choice. If I ask my function, or if I evaluate my function when x equals 2, let's just plug it in. What's 2 squared? Times 6? That'd be 24 over 3 times 4 would be plus 1. This is bigger than 2 or less than 2? It's a little bit less than 2, so it's like right here. Did that just make my decision for me? It's not going to bounce up and over. It's just going to slowly mellow out and get close to this. Now, I'm pretty sure it's going to do the same thing on the other side. We have a function sketched right now. We didn't calculate a whole lot of stuff out of this. Do you think we're right? Let's just check. I'm going to go to Desmos really quickly, and this looks like the last thing that we're going to do, and then we're going to spend the last minute to learn a vocab word. Or we can just save it if you guys don't want the vocab word. I'm also fine with that. I've never heard today's word. What's our function? F of x equals 6x squared divided by 3x squared plus 1. That's what we just graphed. That's exactly it. Cool. So this one I don't think does. Like, I don't think it does. I'm going to check. Nope, it just gets really close. Remember the horizontals? They're the weird ones. They only tell us what's going on at the end. It's okay if we cross them on the middle of our graph. I think it's a pretty graph, but pretty commonly, the type of graph that you'll see do something like this, and I'm just going to do it in this orange color. A lot of the times we'll get graphs that do something like this, where it goes whoop, zoo, and does something like this, where it's okay to cross, we just settle. Okay, tonight, I want you to work the alternate assignment that I had written over here, over here, over here, that one. Yeah, I want you to work this one. If you'd rather do a couple of the odds instead so you can check them, I have no issue. Remember, the homework is your practice. I want you to make sure we're doing this. Tomorrow, we're going to move on past this. I will be here for a little while after school. I'll be here at lunch. I'll be here before school tomorrow. Come talk to me, do some math if you would like. Last little thing. Alaska, during the summertime, we encounter quite a bit of conflagration. Conflagration. I have never seen this word in my life. Conflagration. It is fire that extends to many objects or over a large space. So when you have a big forest fire, if you wanted to sound pretentious, you could say, "Huh, quite a conflagration we're having today," which sounds so stupid and obnoxious, but I kind of love it. All right. I hope your guys' days are full of conflagration. Like, not real fire. Like, I want you guys' days to be fire, is what I just tried to say. Cool.
After